Yeah. Madhur is there, so we don't have to worry about
Okay.
it. Yeah, just give me a minute here. I'm sharing the screen. Yeah, we are all good to go.
Excellent. Good morning, good afternoon, everyone who joined today. Today, we will be talking about how AI is enabling personalized medical services across quality care, patient 360, claims and automation, and others. So please welcome me to Sriram Ganapathy. He's a Microsoft veteran and Microsoft evangelist. Same here for James. James is also a leader in the data analytics space. Welcome, both of you. Thank you for joining this event.
Yep, great. Love to be here.
Excellent, excellent. Hari, your next slide. So as Saxon, we are doing quite a few things around AI and ML. We are building data science model around improved patient care, how to do faster and accurate diagnostic, personalized treatment based on various different touch points that you have across your different services, and also preventive medicine and care. So Saxon is leading healthcare initiatives. We are focused on healthcare analytics. Today we'll be talking about some of the use cases that comes across Patient 360. So the next slide, Hari. Hello? Next slide, Hari. So as you all see that Patient 360 means how they are working with their primary care, their hospitals, their labs, their pharma. There are a lot of touch points for Patient 360. How do we assemble all of this data, IoT, health, home health? So today we have James here. He's going to talk about Patient 360, and based on his experience, what is the evolution and revolution, how innovation is happening across various different services across Patient 360. So James, why don't you talk through your experience around this slide?
Yeah, sure. There's the idea with many solutions is that, or many customers, is that you want to combine all your customer data into one. And whether that it's all done within one system or whether you make it available for other systems to use. And whatever architecture you're using, the idea is that data needs to be combined, it needs to be cleaned, and it needs to be mastered on there. And so within Microsoft, we have, I'll call them shortcuts to building out patient data with our what's called database templates and Synapse, or think of it as a common data model. So there's a lot of things that are already pre-built for you, especially in the healthcare, to go and use these data models as a starting point instead of creating something in our own. And then I could use that for the customers, those data models in there, and map it all, land it in there, clean it, master it, and then I have a 360-degree view. Once I have that, I can utilize that in whatever other applications I have that need that data, and therefore you're getting the single version of the truth, and you're getting this 360 view, whether you want to use it for historical reporting or whether you want to now start getting into machine learning, and how can I use this 360 data to help build those models and make them more accurate.
And what are the challenges? Because you have several touch points, right? You have your primary care, you have your labs, pharma, your home health devices. What are the biggest challenges that you see? Because these are different either custom proprietary solutions that you come across in terms of data ingestion. What are the biggest challenges that you see from structured, unstructured, and semi-structured or unstructured data set? And how do you compile it from a Microsoft perspective into one single view? Because it seems easy to say patient 360, right? Behind the scene plumbing is much harder. So share some experiences from your Microsoft experience.
Yeah, sure. The biggest is cleaning the data. I can't tell you how many times especially when I was a consultant and was working on a lot of data warehouse projects, and they gave me a list of their source systems, and I said, well, we need to put some time to clean the data. And they're like, no, the data's clean. We're sure of it. And I go, I'll bet you $100 right now that I'm going to find some problems, because people find loopholes in the systems. Maybe you have to have a patient birth date in there and they don't know it, so they put some birth date in the future or 200 years ago. And then you start finding all these issues in there. So you need to have a lot of data governance, a lot of time up front to clean the data. So as you're pulling it from these source systems, unfortunately with products like Azure Data Factory, it's got connections to over 100 different source systems. So it's easier to pull the data out, but you still have the challenge of cleaning the data. And then if I pull the data from multiple systems and all those systems have customer data, maybe I'm a big company and I went through we've had a lot of mergers and acquisitions and all this customer data is everywhere. And I pull it in there and I clean it, but now there's duplicate customers in all these different source systems. And they have different misspellings in the name, or they use junior on them. Well, not to master the data, because the last thing you want to do is create this 360 view and have somebody use it and they look at the data and go, well, that data is not correct. Why is this person listed twice on here, the same person? So you need to master the data, which is a possibly long and complex process, but it needs to be done to make the data valid and to make the end users confident that what you built is correct, especially from the beginning. So cleaning and mastering the data is the biggest challenge. Pulling it from these source systems is easier with technology, and also easier because I can at least map it to that one common data model. And so I'm having some agreement from all the organizations on what that common data model is, but the work has to be done to clean it and master it.
Thank you, James. And how difficult it is, as from cradle to life cycle of a patient, you have various different medical providers, insurances and all, to collect all of this into some kind of MDM solution or master data solution, because you're pulling a lot of data from various different things, and you may have duplicate information, you have incorrect information. From a Microsoft experience, explain the MDM part of it a little bit better, a little bit more. How do you see playing it out, especially if you're looking for a holistic view of a patient across its life cycle?
Yeah, to master the data, the idea is you need to use some piece of software that can use machine learning to look at all the customers and come up with some percentage of what it thinks when it thinks these two records are the same or multiple records are the same. And Microsoft does not have any product like that. So I recommend other third-party products like Prophecy, and get a consultant company that's used it before to set it up for you. So you can quickly pull in all this data and then start using these tools. They can be automated to a certain extent. So you can say, maybe if the machine learning has confidence level of 80% or above that they're the same person, just go ahead and merge them, create a golden record. If it's maybe from 50% to 80%, you need somebody to visually look at it and click a button to say whether it's the same. And maybe anything under 50%, you just say it's not the same. But that's a lot of work. You create these business rules. You got to find the fields that you can use, because it's not just the name. You use the address and the zip code and other details that may be available in these systems or may not be available. So those business rules are the biggest part of that, and the percentages you want to use on there. And so you would hope you could automate all that, but most customers, they're going to have a lot of upfront time visually going through it all. And some of the tools like a Prophecy have great tools to do that at a very large capacity. Many hundreds of thousands or millions of records got to be sifted through, and they can do that. And therefore, you're going to have that confidence once you deliver that report to the end user that you've combined all this. I wish it was as easy as just using a task within Data Factory where you can say merge all the duplicates, that only works if everything is about that patient exactly the same, but you're going to find those misspellings, the middle name used, that juniors and seniors use. And then you need other fields like address that you can use to make it easier to see if they're the same person. But it's a lot of work. And most customers do not put enough time when they're building a customer 360 in their project plan for cleaning the data and mastering it.
Thanks, James. And how important is the cataloging or lineage or search as part of this process?
Yeah, a good point of lineage. In the end, when you have that data and you have the customer 360 and maybe it's passed into another system to use, you want to be able to answer a question where the end user may go, well, where did you get this data from? If you have lineage that goes through and shows you all the way back to the source system where that came from, you're going to have more confidence in that. It may be required now with a lot of these laws that you can track the lineage because you may need to delete it in each of these spots. And so Microsoft has a product like Purview that could scan these systems, that could also pull in information when you run a data factory job. It'll pass what it did with the data into Purview, and you can then see as it goes along. And Power BI has the same thing when you can look at lineage from data sets and reports and dashboards. And Purview is combining all this and allows you, in most cases, to see how that data propagated through. There's still some challenges. If you have a Spark notebook or a T-SQL and you're doing all the stuff with the data, it can't yet or may never be able to read that and understand everything that was done to it. But at the very least, you can put in calls to Purview to say, hey, I'm going to push to Purview what we're doing, and then it'll know. And you just got to be diligent about doing that. And then somebody can have that holistic view of lineage of how that data got through, and that will solve a lot of questions that will come about.
Thank you, James. Hari, next slide. Shri is going to be talking about some of the trends that is around smart personalized care. Shri, can you share your perspective on personalized care?
Yeah, absolutely. So we're going to talk about two different scenarios that we are seeing adoption of AI-related services in healthcare, right? The first one is smart personalized care. We're going to talk about another one, which is claims management automation. But let's talk about smart personalized care first. So the idea is that, as a patient, right, if I'm, a patient that wants to visit any provider, I expect the healthcare institution to have access to my medical history so that I don't have to repeat a lot of things, right? Especially if I am somebody that's visiting this facility often, whether it's primary care or anything else. I expect the healthcare institution to have full access and be able to go online and quickly be able to look at my past visits and all that. I think that's sort of table stakes these days, right? So that's one of the trends that we are seeing from a personalized care perspective, from what a patient wants. Now, from the other aspect of it is also how easy it is for me to set up appointments, to be able to go back and again reschedule, all that kind of good stuff. So being able to do things like simple things like booking medical appointments online is something that consumers want as well. And that's what we're seeing. And these are all studies done by various different organizations, right? This is not data that we came up with. These are actual surveys and studies done by various institutions to understand what do consumers want. While some of them may sound pretty simple, you'd be amazed at how many organizations still don't have these capabilities in place. They're still taking calls to book appointments and all that kind of good stuff. Then if you look at from a smart device standpoint, one of the other trends is that consumers are actually willing to wear smart watches or any other tracking devices that measure their health data. If there is good ROI for their investment of being able to wear a watch. Let's say I can wear a watch and go to my doctor's office and he or she can tell me that they can track that information, alert when certain parameters are out of shape in a very personalized manner. I'm not talking about what Fitbit and Apple Watch offers today, which, measures, things like, I think the latest version of Apple Watch can do things like predict your oxygen levels, right? When people have COVID, they can use that, which is pretty good. But at the same time, it's not personalized. I want it to be in such a way that the institution or the provider is able to actually have a better understanding of all the data points that applies to me, and then use my smartwatch to personally target certain scenarios that may help, take action ahead of time. If you please can stay in the previous slide, please. I want to just complete the few other sort of trends that we want to talk about. So we see that the smartwatch and consumers being able to willing to wear that for if there is enough of a result that can make them track their health more smarter, they're willing to wear that. See, other trends on the right hand side, which is on the other side, the wearable medical device market is also growing. I mean, Apple Watch is one of the leading vendors in this space, but we have a lot of other devices, from a medical standpoint that we expect to see growing and make it even more easier for consumers to take advantage of. And last but not the least, patients in the United States who have already utilized virtual appointments. A mind-boggling 50% of patients have already utilized virtual appointments. Obviously, with the pandemic, this has increased significantly, right? Because in the last couple of years, a lot of us do not want to go into a healthcare facility, primarily because of what's going on in the world today. So that's already leapfrogged the amount of transformation that we are seeing in terms of smart personalized care. While pandemic is actually a primary reason for a lot of these factors, it's not just because of that. Even let's say we are post the pandemic, hopefully pretty soon here, people will still have a significant need for these services just from a variety of different reasons, right? It just becomes a lot more easier to manage healthcare in general versus having to go visit a doctor for every single scenario. So smart personalized care in general, we're seeing a lot of trends. Now let's go to the next slide so we can talk about this in a little bit more.
Shri, one question here.
Yeah.
Go back to the first last slide, please. So as you're seeing the home health is going, we have an aging population. So we are seeing in our ACOs and others, there's a lot of care coordination, right? So there's a lot of home health devices like glucometers, pulse meters, weight machines, blood pressure, right? Devices. So all of them, how much of a growth that you see in home health and IoT integration with your clinical systems, and what is the growth pattern that you see from Microsoft perspective?
Yeah, it's a good question. So I think, if we think about the IoT market, primarily the initial focus area has been on manufacturing, right? So you have all of these different factory floor equipment that send data, telemetry, and then you do take some action with it. Surprisingly, like you said, in the last couple of years, pandemic being one of the reasons, but other factors like, the increase in the wearable medical device market that we're expecting to see, IoT's impact in healthcare is also, seeing a significant traction, primarily because of the data that we can collect from these wearables. And like you said, the wearables need not be just something that, I wear as a healthy person that may want to just proactively take some, action, but the older market where, you have people that are in different facilities, long-term care facilities and things like that, where they can do simple things like fall detection, right? So if you're an aging population, being able to do fall detection with which smartwatches like Apple Watch already has in place, but what do you do with that data set? So yeah, IoT as a technology enabler in being able to take action on that sort of data that's coming from these wearables is definitely a huge factor that we are starting to see from an industry trend standpoint.
Thank you, Shri. Hari, next slide. You can continue your thought process, Shri, here.
Yeah, so how is AI relevant? I think that's the whole idea for this discussion here today is, right, how do we take advantage of, AI services to help with some of these scenarios? So we talked about the trends in terms of what's smart personalized care, what we are seeing in the market. So how can you use AI for smart personalized care, right? Is the intent of this particular slide. So one of the examples, right? So there are many examples, but just because we're just coming out of this pandemic, hopefully, is in the COVID-19 scenario, this has been huge in terms of helping screen patients for potential COVID-19 infection and care. So the idea is that, during the pandemic, we didn't want to visit, a facility if we can avoid it. So how can we service patients anywhere they are on any device, right, through any digital channel, whether it's using like a Zoom meeting like this with the doctors and other sort of virtual setups, and then being able to do that in real time, right? It's not about me, sending some information and then later on I get some information back. We need to do this in real time because we want to take immediate action, especially, for an example like COVID-19 infection. We cannot just wait for, a delay in terms of like servicing the patient. So, the AI transformation in being able to use this is very real. And we'll talk about in the next slide, what are the services that are going to be utilized here. But the solution is to be able to, first of all, effectively screen patients for COVID-19 infection using a spoken or a written conversational interface. So you can think of bots and conversational agents in general, where I can have a natural conversation with the provider using an AI service like a bot, which can help screen me as a patient for questions that may indicate whether I need immediate care, whether I can just take some action items and then come back later if need be, without having to go into the hospital or the facility, right? So that's really the scenario here. And the outcome, of course, is that now you're able to deliver much better access to care, and also being able to do that, in a way that can lower the costs for the health provider, because you don't want to be like taking in everybody. So there's a scale issue there, and also for the population itself, it's being able to do that with lower cost. So if you go to the next slide now. So we did build a solution scenario for this, and where we have some customers using this. In fact, one of the big customers that we initially launched one of the screening, the questionnaire for COVID-19 was CDC. So as you all know, CDC has been doing a ton of work in terms of like giving guidance to patients during the pandemic. And one of the things that the CDC did was they actually had this COVID-19 questionnaire on their website, where I could come in and sort of like type some symptoms that I'm experiencing, and the bot will answer back with some more questions based on my, based on my symptoms, based on how I am, answering those questions. It's a very natural language interface versus just a set of question and answers that anybody can come up with. It's using AI to have a more personalized natural language sort of interaction with me. So CDC used that. So the architecture behind it is, think about it as, it's used both for the patients and for the healthcare specialists. So if I'm a patient, I can go to this online screening. So I have a natural conversation with a bot type of an interface. And behind the scenes, I would be able to, based on my questions and answers, have a feedback loop that I can provide back for retraining the agent, because it's not going to be perfect every single time, right? I may be having different symptoms from what I have designed the system for. So having a feedback loop is sort of important from an AI standpoint so that I can learn from it. And then what you see on the right is huge. So one of the things that Microsoft has on our Azure stack is an Azure API for FHIR. So this is a health standard protocol for taking data sources and ingesting into the Azure service in a compliant and secure manner. Because if you're a healthcare provider, you know this better. You cannot just upload patient data or any data without making sure that all those compliance and security standards are in place. And FHIR is one of the health industry standards. And Azure has a FHIR API that you can utilize to take data from various sources that you have. Because it's not just about me asking a question and you answering back. You have to then go to all of these medical systems of record to make sure that the answers that we get back are conformant with all of those medical dictionaries, which means you have to interface with structured and unstructured data that may be sitting in your systems. And FHIR provides you a secure way of taking the data, putting it into a central location that you can then use with a bot service to feed that information back to the patient. So it's huge in terms of like being able to have it in a secure and compliant manner. And then the other persona that you see on the left of the slide is a healthcare specialist. Now, the healthcare specialist is getting all of this information that is being serviced by the bot so that he or she has firsthand information of what has already happened with the patient. So if I do realize that the patient needs to have an in-person visit because all the questionnaire, the screening that has been done, suggests that this person actually needs, personal care, I don't have to repeat all of this information again with this patient because I already have that, sent back to me by this bot service based on all of this other conversations that has happened. And then they can, look at an analytics dashboard to look at all the different history of the patient. So lots of things that you can do from an AI and a care solution standpoint using a scenario like this. I'll pause there. There is some more details of this that we can get into, but hopefully that helps. But Khalil, I don't know if there are any other questions based on that.
Yeah, I have two questions. One is does the FHIR connects you to the EMR, EHR systems, and you can pull the clinical data, which is the patient history and others. So while patient is interacting with the bot, it's also like all the backend data, the lab data, the pharma data, any other hospital services data. Is it also integrated to this like Epics of the world, right? Or Cerner's of the world? Are they integrated as part of FHIR?
Yeah, it's a great question. So the FHIR API in general, it just enables rapid exchange of data through the FHIR protocol, of course. And so it's offered as a PaaS offering in the cloud, right? So that's the first thing that you need to understand. And so it makes it easier for anyone working with health data to ingest, manage, and persist PHI information in the cloud. And doing so, in a matter of minutes versus you having to figure out all the infrastructure that you have to stand to get something like that in place in an enterprise performant manner. And then you can also control your own data at scale with role-based access control. So you can say, I can only access certain parts of the information. Somebody else in the organization can have full access and so on and so forth. Your question is, what about all of these different partners like Epic and Cerner, and how can they sort of play with this? So we already have partnerships with many of those ISVs, as we call them, right? And them working with us and building these sorts of solutions. The whole idea is, how do you securely manage health data in the cloud? Using a consistent RESTful FHIR API that's based on HL7 FHIR specification, backed by a PaaS offering that's in Azure. So that's what the FHIR API is all about.
So it's more like an API management platform. It doesn't have so connectors still needs to be built, right? So if you want to expose the APIs of Epic, FHIR can be the platform that can manage those APIs, consume it, transform it wherever it needs to be transformed. But the connection part or connector part still needs to be figured out.
There is, so good question. So there is an Azure IoT connector for FHIR, right? So that may be so we talked about medical devices and how, getting data from the medical devices is an important part of it. You're right about systems like Epic and Cerner, we can think about how the connection works, and they all have connectors they have built on their own to able to, address that. But from an IoT standpoint, directly from the device data, there is actually an Azure IoT connector for FHIR, which is an optional feature, right? You can or cannot use it. That provides you with the capability to ingest data from any IoT devices. We actually call that IOMT, Internet of Medical Things devices. So IOMT is a term that we specifically use for referencing medical devices. It's a category of IoT devices that capture and exchange health and wellness data with other healthcare IT systems over the network. So some examples of IOMT devices could be fitness and clinical wearables we talked about, monitoring sensors, activity trackers, point of care kiosks, or even a smart pill, believe it or not. A smart pill could be considered an IOMT device. And the Azure IoT connector for FHIR lets you quickly set up a service to ingest all of these data using the Azure API for FHIR.
Thank you, Shri. And second question is, does it also support localization? So if a patient is interacting with a bot, can they speak Spanish versus and still do the localization of their responses, right? Is it all English or at this time, or it supports other languages?
Fantastic question. So the whole conversational AI space, as we think about it, the bot is just the front end, right? So all the bot does is basically takes our user input and response, based on the understanding. Language understanding is sort of like the key capability. And then it says, okay, based on this language or the question that the patient in this case has posted, I'm going to go take an action. Now, there are several other AI services that usually become part of that AI solution or the conversational AI solution. One of them is a language translation service. It's a very, very commonly implemented service as part of it. So to answer your question, the Microsoft Azure Translator AI service is typically utilized to, if it is not, in English language, some other language, to first translate it into whatever language, English in this case, and then have the agent take the response. And then on the back end, again, it can respond back in whatever the target language the audience needs to speak. And so think of it as language translation as a middle layer that would do the translation on the user's behalf and then get the result back. So the architecture doesn't change. You can include the language translation as a way to address the language barriers. And we support, don't quote me on this, some 160, 200 plus languages, right? So we have a language translator offering, which is the best in the industry compared to any of the competing vendors, that has pretty high accuracy rates, that can also be trained, by the way. So one of the questions I often get is, it's great if I can translate Spanish or German or whatever, but medical terminology has some very specific language, right, that also sometimes may not be easily understood by a bot. So we actually can train the language service in this case with domain specific terminology so that it understands medical terminology better than what a regular language translation service can do.
Thank you, Shri. And does it also include any integration like those federal and state guidelines like NANDA guidelines or Macmillan guidelines? Is it also part of this solution? So this basically give you guidance in terms of, let's say you have a cardiac arrest, right? What are the various alternatives for you, right? Does it also have those state federal guideline integrated either through FHIR or other mechanisms?
So the options are up to the implementer of the service to figure out what medical dictionaries and ontologies that they want to tap into to be able to provide that. So we have actually something called, so we have a generic bot that you can use to build these in conversational AI applications. There is also an Azure Health bot. We specifically created an Azure Health bot. That is what CDC is using, by the way. And what we have done there is gotten one step closer, where they're already tapping into many of the medical dictionaries, to your point, that has already been vetted out. And these are like, the primary sources of information. But, anytime I talk to a customer, they're like, yeah, that's great. That we are covering 80% of the scenarios, but there's always this 20% that's custom to what I'm looking to do, right? Maybe I'm in oncology and I have specific oncology related, items that I need to surface up as part of this dictionary. So you can always extend it with custom data sources like that. So to answer your question, yes, we do cover many of those scenarios, but specifically for, like a cardiac, scenario that you talked about, I don't know if that covers it. So we can always send some information on what the Azure Health Bot taps into and what medical dictionaries that we're already working with. But if it's not part of the list, you can very easily, it's an extensible API that you can tap into any of those others.
Very good. Thank you, Shri. The next topic we're going to take is what are the trends around claim management and automation? And Shri is going to talk about some of the trends that is available in industry. Shri, please.
Yeah, so very similar. So the very first, the scenario that we talked about is smart personalized healthcare. Another trend, so these are like two big trends that we're seeing in healthcare and how AI is being utilized. That's the reason why we're talking about these two scenarios. I'm pretty sure there are many else. There are lots of others out there that you as customers may be thinking about, and please let us know. But the other one that we are seeing from a trend standpoint is claims management automation. So this goes into the fact that hospitals have lots of claims that they have to process, right? Whether it's a pharmacy that's processing prescriptions, whether it's hospital intake or admission forms that hospitals are processing. And so that's, the scenario. But what we're seeing in terms of data points, like again, this is from research done by many agencies, is there's a lot of data breaches, right? So security and compliance becomes very important here. So you have to have a centralized system of being able to manage this data versus like you maintaining it in your own in-house system. That's number one. Number two, the number of errors, right? Because these are all manual people that are looking and validating these claims. You can imagine the amount of errors that you could encounter, and that itself can have a huge impact to the organization, especially during COVID times where we are seeing staff shortages in hospitals, right? I think somebody referred to this as just like the Great Recession. They referred to this as the Great Resignation. There's a lot of resignation of nurses and other staff, unfortunately, because of the toll the pandemic has put on health, in general. So we are also seeing staff shortages. And then, what a human can do, one of the other stats that we're seeing is if you're automating some of the solution, it's a lot faster to automate a lot of these claims by having an agent, a robotic agent, do a lot of these claims processing. And of course, you can see the cost to hospitals on claims denial. So claims denial is a huge issue for hospitals. $260 billion is a cost that we have seen to hospitals because of denied claims. So if you can improve the amount of claims that can be not denied, even by a few percentage points, billions of dollars in savings to hospitals, right? So, and then fraud is a related aspect of it. So those are the trends that we are seeing. Now, if we move to the next slide, we can sort of talk about how can AI help again, right? What's a scenario that we have, a solution that we have seen in, with some providers that we have worked with in terms of using AI for claims management automation. Do you want me to continue on, Khalil, or did you have any questions?
Yes, yeah, please continue on.
Okay, so one of the scenarios that we have seen is, like I mentioned, how do we take these handwritten forms and, and then how do we sort of automate and save time and make it easier? So handwritten prescriptions, is one of the scenarios that we have recently worked with, where we can take handwritten prescriptions and make them actionable with a very high degree of confidence and accuracy. So the scenario is that being able to classify and digitize these documents, right, with AI behind the scenes, so that we can have some specific actions and insights, on that data set. So think about millions of prescription claims that are coming in, even handwritten ones. We're not just talking about typed ones, right? Even taking handwritten ones and being able to extract some key pieces of information from these claims, that can then be fed into a downstream system. So today it's done by a human, right? I need to understand what is in the claim, take the key piece of information, type it into another system, and then, so on and so forth. But how about if we can automate that part of, the human interaction that's required by using some AI services? And if you go to the next slide, we can think about like, what is the architecture that we have seen utilized for this particular scenario. So on the left, you have these unstructured prescriptions. And one of the services that we have used with our Azure AI stack, it's an AI service called Forms Recognizer. It's actually a service that uses OCR, and it uses some computer vision techniques and also some language understanding, NLP techniques. And it can read information from things like prescriptions and extract key piece of information. And then you can annotate the text with some semantic markup, right? So you can actually mark up the text, and then you can provide it to your claims investigators or your claims specialist. So all that manual entry process of being able to like take all of this data, ingest them, extract key piece of information is done by AI using our services. We call them cognitive services, but we have specific cognitive services. These are pre-built AI models that Microsoft builds that you can easily use as an API. So the idea is that you don't have to be a data scientist and build these AI models on your own. We have these AI models, we call them cognitive services, that you as a developer now can quickly plug in and utilize and infuse AI into your solution so that you can automate a lot of this. So that's one of the examples that we have seen that has actually resulted in significant savings for a customer that we work with that has been able to reduce the amount of human interaction that it takes.
Shri, you talked about two areas where I saw a big number, right? One is claim denials, $260 billion, and then fraud, waste, and abuse, $68 billion. That seems to be a loss of money for the payers to be either it's erroneous claims or there is a fraud, waste, abuse of some sort, right? What is Microsoft doing in this particular space? Because it's such a green field, even though there are companies emerging and just focusing on claim processing and RPA and AI and enablement. How is Microsoft different in these two areas? And what is the innovation that is happening? Is there readily available solutions that could be plugged in versus it's still a work in progress?
Yeah, great question. So, and so this slide sort of expands on the previous one, right? So there are readily available services. I think that's the short answer. But at the end of the day, you have to stitch together a few of these readily available AI models that we have into an architecture like you're seeing here on the slide. So there's like 4 different things that I'm going to call out. One is this Azure Computer Vision service, right? That's at the bottom of the slide. That can actually take a prescription or whatever other medical document and be able to take key piece of information and classify the documents, tag them, things like that. The form recognizer API that you see is also another AI model, which I just talked about, that can specifically work on documents that are of type forms. So prescription forms, patient admission forms, you name it. And then we also have another service that's on top of the slide called Azure Cognitive Search, which can now take all of the thousands and thousands of unstructured documents that you have in your organization and create a searchable index using these AI services so that I can ask questions on my data. I can now get insights on my data very easily. We call this topic knowledge mining. So I can go in and I can understand, hey, show me all the claims in the last 5 years that have been denied, as an example. And then I can go one step further and say, have they happened in a particular state? Have they happened due to a particular scenario? So I can do all of these different sorts of analysis. And so, that's one of the ways to approach the claims denial scenario, like you talked about, which is a huge cost to providers, to be able to have these AI models do all the heavy lifting for you. But you still have to stitch them together and put a solution where you can, easily sort of get an end goal accomplished. And I think that's a really nice segue, because we have solution accelerators that Microsoft has built for a lot of these different scenarios. One such solution accelerator, we have one for claims management to answer your question, but we have a solution accelerator related to this for patient risk analysis. And one of the things that we did was we worked with the Saxon team here as a partner of Microsoft, and they were able to take this and build it, right, in a very quick amount of time using their expertise. Saxon has a great team of data scientists and developers. They were able to take the Microsoft patient risk analyzer solution and build an end product that hospitals and providers can use. So considering we have a little bit of time left, Khalil, I'm pretty sure you want to talk about what you all did with the solution accelerator that we have in place.
Yeah, thank you so much, Sri and James. I really appreciate the insight. So the next, we're going to do a demo on patient risk analyzer. This would allow us, to the audience to see that how quickly we can turn patient insight and patient medicine and treatment and everything else in a visual format. So either Yogesh or Madhur, one of them can take it over here. Madhu, you want to share your screen, or Yogesh, one of you?
Yeah, Khalil, I'll just share my screen.
Okay, thank you, Madhu.
Is the screen visible? Can you confirm?
Yes, sir.
Okay, so this is the patient risk analyzer we have, and it is an end-to-end healthcare app, basically. Which is leveraging the machine learning prediction models like diabetes mellitus, and it is demonstrating how these models can provide insights for both doctors and patients, and we'll just see in demo how it all works. So this is the basic architecture of the end-to-end model. This is doctors, and this is the front end Microsoft Power Platform. We have the source data available in the Azure Data Lake storage, and we are loading the data in Azure Synapse Analytics, and we are doing all kind of machine learning transformations in there using Spark cluster, running all kinds of machine learning algorithms, test and training the data. And we are taking help of Auto ML model, which is very fast compared to the traditional way the machine learning model were trained. And we are just creating a Docker image of all that model and hosting it in Azure Container Registry. From there, we are deploying it directly to Azure Kubernetes clusters. And also the predictions of the model based on the machine learning algorithm the predictions are loaded in Cosmos DB, and the API of all these are fed directly to the Power Apps, which is the front end for doctors to see. And it is passed on to the Power Apps with the help of Flow, Automate Flow, different APIs, and doctors can see there in the real time about the health of the patient and what possible conditions he might have. And regarding the patients, we can also build upon this and provide a front end for patient to communicate with the application, and maybe use different text to speech API and other cognitive services, and which could be a good extension to this. So I'll quickly take you to the Azure portal and quickly show you the demo around it. This is the ADLS storage, and these two are the main data sets we have, source data sets. The rest are all created by machine learning algorithms. These are like open source data set, so we are using this. This is our Azure Synapse Studio, and here we are running different kind of notebooks with Spark cluster to process this codes and to test and train the model. We are preparing the data, then training, test and training the model with 50-50, and then we are deploying ultimately to the Kubernetes, and then loading the predictions into Cosmos DB. Just a minute. Yeah, so this is the Cosmos DB we have. It is all the predictions are loaded here in this container, patient hub DB, and these are all pointing directly to Power Apps, as I mentioned earlier. All our machine learning model was created here in the studio from Synapse only. All the experiments and the different models. This is our Power Apps, and this is our analyzer accelerator. Basically, opening that will make us reach on this page, and this is the front end, what a doctor can see, and he can play around with all the settings, all the configurations, and filter out the settings he want. And these are the profiles of different patients, which was the details of which were provided in the source dataset. And by leveraging the machine learning models, it has provided different predictions. Based on it, we can open a particular patient's profile, and we can see the chances of heart disease and stroke and all those things. And also we can, doctor can communicate about different upcoming appointments that particular patient has. So it is very helpful for the doctor. In one place, he can search and sort and just play around with the data of the patients with the predictions. And also what we can build upon this is the patient side of a front app, which we can, like Shri earlier mentioned about the different translation service the cognitive service provides in real time, and the text to API and text speech to text and text to speech API, so that he can communicate with the Power App in real time and like check his history and upcoming appointments and all that. So this was basically the end-to-end architecture of this patient risk analyzer.
Hi, this is Surendra. I have a question related to the earlier visualization. It's a good visualization, but the question I have is related to how it is predicting if a person has heart disease or diabetic. Like, is it based on the data it receives, or Azure has that capabilities to predict what? Go ahead.
Yeah, sorry. Azure like doesn't itself has the capability, but it is leveraging the machine learning model, and the data of the customers are provided in the source data set, and it is using those data to prepare a machine learning algorithm here. And in this algorithm, it is training the data accordingly and using the algorithm to predict the all those things, the heart disease and all those things.
So it's basically from the diagnostic information. Go ahead, sorry.
Yeah, so that is usually coming from the EMR or EHR system. So every patient has a clinical history, right? If they have patterns and others in terms of history, their medicine and all. So there's a lot of data being collected behind the scene through your Epic or Cerner or Athena Health or some custom clinical system, right? EMR system. Then in addition to it, there's lab data, there's pharma data, there is history from cradle to life cycle of the patient. There's a lot of history that is coming across, and even some of the EMRs, or if there are findings in terms of diagnostic, right? Image diagnostics and others, that is also could be put into it. So history of the patient, and then the AI model makes it further, say based on this history, what can be the probability of this person having a heart attack in 2 years, for example, right? Versus 5 years or immediately, right? So one of the study that we are doing for another healthcare provider where they are looking for their risk population. What it really means is like, if I have like, let's say 1 million patients who are my risk population, right? So there are 80% of them who have normal health and I need some care for them, regular care, some requires palliative care, some require hospice care. How do I identify it? Who are my chronic patients, right? Who have diabetes and blood pressure and cardiac and rest of it, right? So this model is the AI part of it, but behind the scene, there's a lot of data ingestion across multiple systems that provides a basis of it. Did I
Thank
answer
you.
your question?
Yeah, that
Yeah,
answers my question.
Yeah, just to add to that, yeah, I think you're all absolutely right. So yeah, so the Azure itself doesn't have like a model that will predict, heart attack as an example, right? What it does is, so there's a machine learning model that, you have to build. That's the heart of the solution. But Azure has a tool called Auto ML. That's one of the specific services within Azure machine learning that will automatically build machine learning models for you. But it relies on the data, like Khalil said, where if you have a lot of data that you've collected over a period of time that you can then use to train this model, Azure makes it very easy. The Azure Machine Learning Service makes it very easy where you say, here's my data set. I'm not a data scientist. Can you please build some models for me? And Auto ML feature within Azure ML will build the models for you. And once a model is built, you can choose which model that you want to use. And now you may want to bring in a data scientist and sort of like understand, what it has done behind the scenes. And then you can implement a machine learning model, which can predict that heart attack or whatever the case may be, right? So that's really the way it works, is you can let the platform build models for you very easily.
All right, thank you.
Thank you, Shrey. I think we are at the tail end of this. Any other questions any one of you have that we can answer today? Hari, we can wrap up. So you can switch to the last slide. So first of all, I want to thank you to my co-panelist here. Thank you, James. Thank you, Shrey. Really appreciate your insight. I want to plug in some of the details around Sexson. We are a data management analytics company that is focused on data science, AI, ML model across healthcare. Healthcare is our bread and butter. So any one of you would have larger questions or want to discuss your situation, please come to us. We are cloud agnostic, technology agnostic. We are Microsoft partners, multiple partnerships around data management and data science platforms. We are a global company. So more than 600 plus people across the globe. Look forward to a larger discussion with some of you. Please reach out to us at Sexson.ai. And thank you again for the time and opportunity to present some of the AI use cases to you. Thank you.
Thank you. Good presentation.
Thanks all.
Thanks all. Bye.